Hello, hi everyone, and welcome to another webinar of the OpenTalks series. This webinar is about reinventing IT operations. I'm Alessandro Richiello, and I work as a specialist solution architect in the Telco Center of Excellence of Red Hat. Today, we will see an interesting use case for leveraging Ansible automation platform and artificial intelligence for ITSM automation. In case you have any questions during the webinar, please use the Q&A section. My colleagues, Alexei Rushakov and Beatriz Ortega, are here to help me in answer your question while I'm talking. So let's start. First of all, I think that many of you will recognize the Ansible logo, the de facto automation tool that I bet many of you are already using. Thanks to the Red Hat's proven open source development model, the Ansible project has grown with a dedicated community that contribute every day with several resources focused on ensuring that collaborative innovation remains at the core of the Ansible experience for all the users. This success means more open source innovation, as you can imagine. So as the community explore the next generation of Ansible use cases, Red Hat is there to help and make them enterprise ready. Talking about enterprise, anybody can automate something. It could be a script, a standalone playbook, but usually enterprises, however, need more than a just simple automation. Enterprises need coordination, scale, audit, high availability, and so on. These needs, matched with the respective domain, create a common challenge for many organizations. In many teams, for example, it's common to have multiple domain-specific tools for the automation. Networking has its own tools, so does the infrastructure, and also the security does. So these tools are rarely integrated with each other, and additionally, these teams are often isolated from the other teams, meaning that integration across the teams is often limited. IT automation can bring the necessary change to tackle these challenges. So first of all, integrating the different tools within the various different domains and breaking down the silos between the various teams. And if you think about it, that's really the purpose of the Ansible automation platform. Ansible automation platform can fit the entire automation team. It can support on content creation, for example, for developing the actual Ansible content, such as the Ansible playbooks. The operation teams could use the automation platform and configure the automation execution. And then finally, the architecture could be adapted to the use case and the needs to get the right automation tools to all employees and make the correct investment in future projects. At the foundation of the Ansible automation platform, we have Ansible Core, which has several features. I usually start from the right, this slide. First of all, my favorite feature is agentless. So it's not requiring any installation or maintenance of agents on the target system or the devices, network devices, for example. Then it's powerful, thanks to a single universal language that lets you automate multiple domains. And finally, the human-readable language makes it simple, lowering the adoption time. Ansible Automation Platform is more than a web interface for managing your Ansible playbooks. It is evolved a lot from the existing Ansible Tower product, if you ever used it. Now, we have a full list of tools for supporting the automation creation, for example, and a lot of configuration to support the platform deployment and the administration of the platform. We are not diving into every single feature. On our Red Hat web portals, you can find a lot of resources describing each one of them. Finally, let's talk about the ecosystem. Red Hat, like for any other product, worked deeply with its partners to offer certified and co-developed content, providing a unique end-to-end customer support experience. There are more than 180 certified content collections that are actually supported by over 70 technology partners to cover, as you can imagine, multiple use cases. Ansible Automation Platform helps solve big customer challenges also in telco, media, and entertainment space. And as you can imagine, we have several TME customers around the world leveraging Ansible Automation Platform. You can find some of them in this slide, such as Comcast, Telefonica, T-Mobile, Swisscom, and so on. The Ansible Automation Platform and its leadership is also confirmed by one of the latest Forrester Wave for infrastructure automation. Forrester underlines the Ansible Automation Platform capabilities in integrating technology silos with low-code and event-driven automation, all powered by a great community of partners. But now let's move on the use case we are going to deep dive today, the ITSM automation. IT service management, so ITSM, refers to the activities that an organization performs to design, build, operate, and maintain information technology services offered to internal and to external customers. ITSM is built on the idea that IT should be delivered as a service. So, if you think about it, ITSM should be backed by a lot of automation. That's why an Ansible Automation Platform is foundational to improve the workflow supporting the ITSM platform. This is also confirmed in a study by Gartner, stating that organizations must adopt automation to improve existing change or for building new management practices. For that, the Red Hat Ansible Certified Content Collection for ServiceNow ITSM helps you create new automation workflows more quickly while establishing a single source of truth in the ServiceNow Configuration Management Database, the CMDB. So the integration between Ansible Automation Platform and ServiceNow is already available today. With the Ansible ServiceNow collection, you can do multiple things, as you can see from the slides. This is just a logical architecture. First of all, you can enable closed-loop automation to simplify the opening, the updates, and the resolution of workflow items, update the CMDB with the relevant and accurate information across disparate users, teams, and assets. And finally, you could also automate incident response and provide a consistent audit trail. But, as you can see from the diagram, for starting a new Ansible automation from ServiceNow, you need to add or change a workflow within the ITSM platform itself. This step is needed to match a proper condition to then start the configured automation via Ansible Automation Platform. But what if you do not want or you cannot change your ITSM workflows? Let's discover. So for leaving the ITSM platform as it is, we could develop a sort of AI agent that could, first of all, read the ITSM ticket, then understand the known issue reported in the ticket via an AI model deployed on top of OpenShift AI, and finally, execute the right automation on Ansible Automation Platform. In this way, we are not introducing any changes to the ITSM workflows, neither in the monitoring tools. The IT user will interact with the ITSM platform as they did before, with a natural language, while the operation team stay in the loop, helping training the AI model, but also approving, for example, any critical automation, as you can see from the right bottom of the slide. Of course, this kind of use cases are some prerequisites that we are going to deep dive. First of all, there should be some data gathering and categorization. In fact, historical ITSM data must be collected and categorized to understand incident patterns, enabling effective automation development, and of course, the AI/ML model training. Then there should be even some development on the Ansible Automation Playbook. In fact, based on the incident data analysis, Ansible playbooks should be created to automate the most frequent and time-consuming tasks, to maximize the return of the investment for the automation. Of course, what we are going to see today is just an example developed to show you the product capabilities. Any of the custom component could and should be adapted to your existing environment. About the Ansible playbook development, AI could help again thanks to the Ansible Lightspeed Coding Assistant. Ansible Lightspeed is integrated with the new IBM Watson Code Assistant that is infused with a specific foundation model that has been trained with open source Galaxy content and additional Red Hat subject matter expertise. So AI could help again even in the Ansible playbook development as we are seeing in this slide. Before dive into the ITSM use case, let's make a step back introducing the Red Hat AI offering to have a clear picture of the whole solution. As always happens, Red Hat selects, collaborates, and drives several different upstream community projects that then decide to integrate, stabilize, and support in an enterprise product. This happens also for Red Hat OpenShift AI and Red Hat Enterprise Linux AI. Red Hat OpenShift AI is a full pre-integrated AI MLOps platform focusing on, first of all, model development, supporting the integration between multiple AI ML libraries, frameworks, and runtimes. Then on model serving and monitoring, of course, thanks to the underlying OpenShift layer. After that, also concentrating on model lifecycle management, expanding DevOps practices to MLOps ones, and then scaling the infrastructure to meet the workload demands. And as you can imagine, we don't stop there. You still get access to the entire ecosystem, including the set of 30 or so AI/ML and other type of software technology partners certified for our platform. So thanks to that, the customers can build and deploy their intelligent application on top of all of that. Now let's move forward to the ITSM automation use case. In very few moments, you are going to see a real multi-product demonstration involving OpenShift, OpenShift AI, and Ansible automation platform. We are going to see in action how after an incident creation on ServiceNow, that you can see on the left of the slide, an ITSM interface running on OpenShift will pull any new and unassigned incident for the classification. Thanks to the text classification, a known issue will be identified for matching the proper automation to execute via the Ansible automation platform that then you see again at the right of the slide. This text classification is executed via the inference of an AI model running on top of OpenShift AI, while the automation will be executed on Red Hat Enterprise Linux systems. But as you can imagine, they could be whatever endpoint or device supported by Ansible, like for example, network devices. For time constraints, we are not going to see the supervisor approval that you can see at the right of the slide, but consider that this is just an Ansible automation feature, so you could enable it very easily in the product. Finally, during the next demonstration, we are going to leverage an existing platform already configured to show you the use case. In case you want to look in how we built this demo, please take a look at the Telecom AI experiment repository in which we documented all the steps needed for the configuration. And don't forget to follow the repository because, as you will notice, we are adding a lot of new use cases. Now it's demo time. Let me share the demonstration. You will see in a very few seconds. Okay, you should see my video coming. Okay. Moving to the live demo, as you can see here, we are going to demonstrate the whole solution through our web browser. We are currently looking at the ServiceNow web interface, and in particular, we are in the incident page. As you can see, the incident list is now empty, but very soon we will create new incident that will be managed by our AI solution. We also configured an Ansible automation platform. As you can see, we are in the jobs list page. The job is the running execution of an Ansible automation template. An automation template is the combination of an Ansible playbook, the credentials to use, and the target host to connect to. Of course, the list is empty, but very soon our solution will start new automation jobs for resolving the incident that we will create. As we mentioned earlier, consider that all the platform I'm going to show you today are already configured and integrated for the automation use case. So we are not seeing the real configuration. Under the hood, we configured a set of Ansible templates, as we mentioned earlier, to start the issue resolution process on the target system. We configured several templates for handling multiple known issues, and we will deep dive in these categories of known issue once we will take a look to the OpenShift AI environment that we configured for this purpose. Moving to the next platform, we also configured an OpenShift container platform, as we saw in the architectural diagram. We are now in the OpenShift interface, and we are logged in with a limited user named user1. You are looking at the OpenShift topology view. And in detail, in an OpenShift project, we created two microservices. The first one on the top is actually interacting with the machine learning model running on top of OpenShift AI. The other instead, at the bottom, is the one interacting with the ServiceNow platform and with the Ansible automation platform. Then we also configured an OpenShift AI platform, as we saw in the architectural diagram. You are now looking at the OpenShift AI web interface, in which we logged in leveraging the same authentication method of OpenShift. So we are the user one. And we created a data science project with a running workbench. Imagine the workbench like a self-service environment where a data scientist could easily work with an AI ML model. We will see in a very few seconds that the workbench is an instance of Jupyter Lab. And as we mentioned, this is a self-service environment where actually the data scientist could clone a Git repository. As you can see from the left bar, we did it, in which we created 3 different Python notebooks for working with our AI model that we will expect really soon. The first Python notebook that we will see in a few seconds is used for training the model that we are using in our AI solution. At the very beginning, we are setting up the prerequisites for working with AI models. We are installing some libraries. For some of them, we are just installing the CPU support, because as we will see very soon, we are not leveraging any GPU accelerator for this demo. Then, after that, we also set up some utilities needed for working with the large files over Git repositories, like the Git LFS utility. This is needed in case we want to upload our model on Hugging Face, for example. Talking about Hugging Face, in fact, we also are defining a function for logging in Hugging Face portal, a very famous AI community portal for working with models and dataset. And again, talking about dataset, we are leveraging a synthetic artificial dataset generated by us. It's a very small dataset, just 900 incidents, but it's enough to show you this example. In the reality, you would use the historical data extracted from your ITSM platform. After that, we are defining a preprocessed function to truncate the text for the model we are going to use. The model is a BERT model that works pretty well in this kind of multi-level text classification. In addition to that, thanks to the small dataset and by using this BERT model, we are only leveraging CPU. So we are not going to use a graphic card for this demonstration, as we mentioned earlier. Then we define a function for evaluating the accuracy of our model. This function will be leveraged deeply during the training of the model itself. And finally, as you can see, we are now in the training section. First of all, we are going to define the labels and the IDs and map them to each other. As you may notice, we are just defining 3 labels for 3 known problems. We are trying to identify 3 known problems happening for a web server, a database, and a generic file system issue. So We have just 3 categories, but of course this could be extended. We are leveraging a multi-text classification, so it could be extended also for covering more specific and detailed use cases. The last step of this session would be defining the training arguments needed for starting the process. And as you can see, there is a lot of stuff here. Now the model training could even begin, but as you can imagine, for a time constraint, we are not seeing this live. We already did it before. And so we can move forward after the training, also uploading the model to Hugging Face in case we successfully log it in to this portal. We are coming to the testing phase. We are now ready to test the model. We will execute this step live in the demonstration, so you are going to see how the model is behaving. And of course, we are leveraging the model that we trained previously. As you can see from the code block, we first define in a variable a text example containing the description of an issue for a web server, reporting of some errors that we got on a system, for example. This could be the example description of an ITSM incident that we grabbed from ServiceNow. To actually test the model, we are creating our classifier, as you can see in the next code block. Again, we are creating the classifier from the model that we trained previously, and then we pass the text description of executing the text classification. Don't mind about the red box. Many of the messages are informative, while the errors instead refer to the fact that we are not using any GPU. So, I mean, the library is trying to access to a GPU, but there is no GPU, so they are going to use only CPU. As you can see, the result is something different from what we are expecting. In fact, the incident has been classified as a file system issue. So moving back to the description, reading the word text description, we may realize soon that despite the fact that we are mentioning a web server, we can see that it states that there is some error with the files that should be served by our web server. So the file system classification was actually correct, and the model did its job properly. So we trained it successfully, and it was able even to identify the issue, even though we are stating that we are experiencing this issue on a web server. We are simulating the incident description, as we may get from our ITSM platform, as we mentioned earlier. As you can see, this is just a natural language. These are some sentences in English reporting the issue encountered and some comments on the errors that we got. For executing the model as a service in OpenShift AI, we need to convert it in an OpenVINO format. OpenVINO is one of the model runtime servers available in OpenShift AI. We already executed this conversion, so the model is ready to be uploaded. We could upload the model with a second Python notebook. After setting up some prerequisites, we are going to define the function for uploading the model on the configured S3 storage, and finally, we will start the service. Luckily, for speeding up the demonstration, we already did these steps, so the model is already uploaded and running on a runtime model server on top of OpenShift AI. We can now move to the OpenShift AI web interface to have a look to the configuration that we already did, for example. So moving to the OpenShift AI web interface, as you can see here now, in the top bar, as you can see, we have several tabs under the data science project name. One of them is data connection. The data connection section where we defined the S3 storage details that are actually connected to our running workbench, the BERT WV. Then we can move to the model section, and we can see that we already created an OpenVINO model server. We will see in a very few seconds, clicking on the name, that the server has a small amount of resources, as we mentioned earlier. We are just leveraging CPU, and we are not using any GPU accelerator. Then, moving to the deployed model, as you can see, there is the model named ITSM tickets, and it's running. This is demonstrated by the green check mark. And also it has an inference endpoint. We have REST URL served in HTTP and also a gRPC endpoint URL. Of course, these URLs could be secured and exposed even externally to the OpenShift cluster. We are now ready to test this REST inference endpoint that we just found in OpenShift AI interface that is actually serving our AI model as a service. So coming back to the Jupyter Lab interface, we can move to the third and last Python notebook. First of all, we are setting up some prerequisites. And then we define, for example, the model name, as you can see in the next code block, the REST URL, and we finally build the complete model URL that we will use for our testing. After that, we need to define a function for interacting with the model service. We are just preparing the input text, and we are creating an HTTP post request for our service. And finally, we are ready to execute the function and get the prediction for our example text describing the issue. As you can see, the text is the same we used before. So we are going also to expect the same result that we got before. So by just selecting the code block and hitting the play button, we will see very soon that we get an array of probabilities, and we can guess that the most higher one is actually the one mapped with the file system label. Let's see this in action with the last code block. And as you can see really soon, after clicking the play button, the incident has been classified as file system. So it's actually worked as we expected and as we tested before. So in OpenShift AI, we just saw how we configured the running model. All is ready under the hood for starting the real workflow and see what happens on our AI solution. We are using a web terminal directly in the Jupyter Lab environment. And in particular, we created a Python script that will interact with the ServiceNow APIs for creating automatically some new incident for the ITSM platform. As you can see, it has just created 3 different incidents specifying the target host and the text description for the issue encountered on the system. So, for example, we have node 1, node 2, and node 3. For some of them, we are reporting that there is a database performance degradation, or we are getting some error on a web server, and so on. Moving to the ServiceNow interface and hitting refresh, we can see very soon that there will be 3 new incidents created. These new incidents are in state new, as you can see, and they are unassigned. So they will be grabbed by our AI solution very soon to be classified, so for starting the process. Again, there is a description and all on the details that we defined in our terminal. So moving to OpenShift, let's see our AI solution in action. We are going to inspect the logs of the microservice service interacting with ServiceNow. And as you can see from the logs, the microservice is already pulling down the incident description and trying to classify every incident. A classification in the meantime has been made for each of the 3 tickets. And this means that an Ansible job is then started in the Ansible automation platform. So as you can see, we also have the classification together with the Ansible job ID. So the process is working under the hood, trying to even solving the issue. So we can move back to the ServiceNow user interface, and refreshing again, we can see that the tickets are now in the state in progress and assigned to our service user named Incident Manager. So this is just a service user that we created for letting Ansible interacting with ServiceNow in a proper way. Let's move to the Ansible automation platform. And as you can see, there are 3 issue resolution workflow jobs running, 1 for each incident. As we mentioned it before, an Ansible job is the running execution of an Ansible template, and a template is the combination of an Ansible playbook, the credential, and the target host to connect to. So our microservice passed to the Ansible job the target host to actually work on, and the classification discover to let Ansible to try to solve the issue. Inspecting one of these workflow job, actually we decided to create a workflow to map and link several different playbooks in a complete process. First of all, as you will see, I'm just zooming in the workflow. As you can see, the first action would be start posting some messages, then upload system logs, and finally try to execute the resolution. In case of success, we post again the logs to demonstrate to the IT user that the issue is resolved, and at the end, we resolve the issue by posting a message in the ticket on ServiceNow. But in case the issue will fail, as you can see from the other branch in red, we actually try to reassign the incident to another user for manual intervention. So actually, we are just redirecting the resolution to a human. In the meantime, all the workflow jobs have successfully completed. And so moving back to ServiceNow and refreshing the page, we should see the changes. As you can see, the tickets now changes state again. Now we have 2 incidents in state resolved and 1 that is still in state in progress. This ticket has been reassigned for manual intervention, as you can see, to another user named problem administrator. It's just, an example user, but it could be whatever user in your organization to actually double check what is happening. Let's inspect one of the incidents that was resolved successfully. As you can see, we have several messages posted directly by Ansible in the incident. We also have logs and information attached. This, of course, is just an example, but we could customize the process as we want. We are leveraging the Ansible certified collection for ServiceNow to manage any existing incident on the ITSM platform. So, moving back to the incident list and selecting the one that is still in progress state, as we can see, Ansible Automation Platform tried to execute the resolution automation, but it failed. So the workflow moved into the other branch, the red one that we showed before, and reassigned the incident to another user for manual intervention. This actually ends our demonstration. We saw how it could be possible to integrate Ansible Automation Platform with a machine learning model on top of OpenShift AI. But let's move back to the slides for a final wrap-up. So I will stop the video sharing and move back to the slide. Okay, now you should see the slide again. So let's summarize the goals, the challenges, and the benefits of the solution. The main goal of the use case is to increase the automation of the ITSM processes, to reduce manual tasks in daily operation, and to reduce the associated costs while improving the efficiency. We developed this solution to try to overcome any limitation on the changes needed in the ITSM processes and in any monitoring tools, as you can imagine. With this solution, just to recap, you will not touch your ITSM platform, neither your monitoring tools. Finally, reducing the changes in the ITSM tool can help in saving cost and time for this kind of projects. And then, of course, leveraging Red Hat products will also help in reducing any third-party lock-in. I hope you enjoyed this presentation, and I invite you to get in touch with us if you want to know more about this solution or about any other Red Hat product. I really want to thank you so much and best regards. Let's see again in another webinar.